Well, thank you, Bob, and thanks to all of you for joining us today. As Bob has mentioned, my name is Ben Nemser. I'm the CEO of Nemel Electronics. Danny Ritz is our VP of Engineering. Nemel is a manufacturer of cable for the broadcast industry. We've been doing that for over 40 years from our Miami plant. We're here to talk to you today about fiber optics in HD broadcast. We like to make this a practical demonstration, hands-on. You'll see Danny doing things that you would probably deal with on a regular basis if you work with fiber in the broadcast world. And we'd love to answer any questions that you might have. I'm going to start with a short video showing our plant, and you'll see some of the equipment that we use to make these products, which you'll then see in detail in the PowerPoint presentation. We'll go through some basic theory. For some of you, it may be old hat. For some, it may be new. And then the interesting part of the presentation, Danny will demonstrate some of the equipment, some of the technique we use for especially cleaning and troubleshooting fiber and HD broadcast. Welcome to our plant. It's a 12-channel audio cable going into DT12 connectors, manufacturing Teflon insulators, that's a planetary cabler. That's the actual machine that we use to manufacture SMPTE cables. And braiding, we'll talk about that briefly. Final extrusion. And SMPTE connector termination. Don't try that at home. And the finished product, one of them anyway. Fiber polishing. And that is our plant, and we'd welcome any of you to visit us at any time. So we're going to get into our PowerPoint presentation, fiber optics for HD broadcast. We're going to discuss a number of points, starting with the system concept approach, a brief history of cabling and broadcast from analog to where we are today, why and where we use fiber in AV and broadcast, the different types of fiber cables and connectors that you probably deal with or will deal with, some of the future standards that SMPTE plays a big role in, and then the demo of termination and troubleshooting and cleaning, which is really, really interesting. So when we talk about system concept approach, I'd like to use an example of a major project we were involved in over the past couple of years. It was a 500,000 square foot broadcast facility for a major network. One of the large systems integrators did the actual design, and the design was very good until you looked at it in detail and counted the number of termination, connection, and patch points from the beginning of the signal to the end. And while the overall distance was well within limits, each one of those terminations introduced degradation to the signal, so it never made it to the end. And we came in after the fact and did a workaround. So the point is, when you do these designs, whether it's one piece of equipment or a major facility, you've got to consider every single point along the way, as well as the individual distances and the performance impact. When we look at the history, some of you may be close to my generation, you know, basically Civil War. When I started in this industry, you could use a coat hanger to carry a signal, whether it was an RF, which, you know, we did in ham radio, or an audio signal. And each successive change in technology gave us a higher data rate, higher bandwidth, and required more and more precise cabling and connectors. And there have been many, many changes in this evolution. And one of those is to illustrate a point in time about 10 years ago. The 3D standard was a viable standard, and many of you may have worked with it. So we got invited by one of our clients, you can see them in the back, to the second to the last launch of the space shuttle in Cape Kennedy. And at that point, 3D was such a viable standard that NASA had requested filming that shuttle launch in that format, which is what we did. And of course, that came and went, and a lot of people don't even remember it anymore. So talking about why we use fiber and why fiber has become so important and becoming more important, this chart gives you a clear illustration in numerical terms of the difference in the performance of many of the standard broadcast cables as we step up the data rates. So using it as an example, a typical RG6, which would be a Belden 1694A, you can see that in the NTSC world, that cable would go in meters over 500 meters, so 2,000 feet plus. By the time we get to the 3 gig range, it's now lost 85% of its distance capability. Now, I want to point out that the last column is the 12 gig column, and there is a SMPTE standard, a ST 2082.1. None of the standard cables even have an entry in there. There are 3 high performance or 12G coax cables that do have an entry in that column, but I'd like to make a couple of points as it relates to the choice between copper and fiber. You'll note at the bottom that all of these distances are recommended values, and they can vary, and I'll add the vary dramatically based on particular installations. So these numbers may be great on a perfect day if it's 59 degrees, if the termination's perfect, if there's no bends, and everything else is perfect and the sun's shining. You'll also notice that there's a big difference in the way that we measure what is suitable for 12G, and it's almost at the point where everybody's got their own idea as to what it is that's going to work. But the numbers that we're used to dealing with in terms of attenuation and return loss are drastically different in 12G, 12 gig, as opposed to some of the lower rates. The point is here that if you've got to make this choice, you really want to consider, if you get even close to what these limits are, you may want to consider fiber, which is going to solve a lot of problems. These same considerations and degradations in performance apply to triacs as well as to coaxial connectors. I take a second here just to emphasize that there have been many, many changes in the RF connectors that we use for the 3G and the 12G standards. And I know this is copper, but it's amazing how many people may not have seen a mini BNC, which is sometimes called an HD BNC, and how easy it is to confuse it with a BNC, which now comes in about 10 different varieties. So the point is, an HD BNC does not mate with a BNC. It's about half the size. So please be careful if you're called upon to buy any of these things. The same thing applies to the mini DIN, which is something we didn't see very often, but now we see a lot more in the higher frequency world. So we've seen these limitations from copper, which leads us into where and why do we use fiber optics. And fiber today has pretty much taken over our industry. You've probably seen it in almost every aspect of broadcast facilities, from studios to event venues, stadiums, and production houses and so forth. You'll find it anywhere from the most advanced facility of a major network down to somebody's garage who does maybe DJ work on a weekend and has a mixer or a console, and you'll find fiber in there. We use fiber to extend almost every type of signal that we used to send exclusively over copper. And in many cases, there were very, very drastic limitations in distance, HDMIs and so forth, where you can now put that over fiber and go for miles. In addition to the drastic improvement in bandwidth and losses, there are many other benefits that fiber gives us. Number one, a fiber cable is substantially smaller, substantially lighter, substantially less expensive, substantially more flexible, and has no issues with EMI, RFI, and so forth. Looking at a graphic display of the comparison in the distance capabilities at a couple of different SMPTE standards on the bottom, you can see even your high performance RG11, almost a half-inch coax, doesn't even make it to the first line compared to a single mode fiber, which goes off the chart at any one of these data rates. In terms of the size and weight, we have a graphic display of the difference between a typical digital audio cable in the top compared to a single mode fiber, that's the yellow line in the bottom part of the slide. About 1/10 the size, 1/20th of the weight, carries hundreds of times the information over 1,000 times the distance for less cost. So what is fiber? Basically, fiber is a glass core surrounded by typically several layers of coating or cladding. Now, this slide illustrates a single mode fiber which has a 9 micron core. That's 9 millionths of a meter. That's a pretty small number. A typical cladding will give you 125 micron initially. That would be the part we would strip to that would go into the contact, and you'll see that in a later slide. But the part that we normally work with that we touch on the outside would be a 900 micron. Now, you can see the core in this particular case is 9 micron, but on the right side, it's showing a larger core, which would be a multi-mode core. Multi-mode is typically either 50 or 62.5 microns in diameter. That's important to know. And again, one of the themes of the presentation is to make sure that you have all the questions you need to ask and answer before you purchase a fiber, specify a fiber, change or replace a fiber. So the first thing we looked at is it single mode or is it multi-mode? And you can see there's a drastic difference in the way that the light travels. The single mode, being the narrow 9 micron, only allows one focused beam of laser light to go straight through the center, giving it incredible performance. The multi-mode, being 5 or 6 times wider, allows multiple paths or modes. So the performance is going to be substantially less. Now, it used to be years ago that multi-mode was the least expensive, more common type of fiber. That has reversed. Single mode today is substantially less expensive than multi-mode, plus it has much, much better performance, and it's pretty much taken over the broadcast world, but there's still plenty of multi-mode out there. And in terms of multi-mode, if you do have to buy some multi-mode, you need to know which one of these multi-modes is going to be appropriate for your application. So we mentioned that there was a 62.5 and a 50 micron core. However, within the 50 micron core, there are various levels of performance. We call these OM3, OM4, and there's even higher after that. So an OM4 is a direct replacement for an OM3. So it's not going to hurt you to put that in, but it's not for an OM1. The diameters are different, and you can see the performance is drastically different. Comparing the performance of even the relatively high performing multi-mode OM4 to single mode, you can see that the multi-mode has about 5 times the attenuation, nowhere near the bandwidth, and not even 1% of what the distance capabilities are. For those of us who come from the RF world and we like to know what the frequency is for the wavelengths, you may have noticed in the last chart that the typical wavelengths we use in fiber for single mode would be 1310 or 1550 nanometers, again, billionths of a meter, which is somewhere in the area of 10 to the 14 in hertz. There are other wavelengths used, and in many cases we can multiplex or mux many different wavelengths over a single fiber to get even more information. The next major question we have to ask in specifying a fiber or identifying a fiber is the construction of the cable. Is it a distribution type construction, as you see here, where each one of those colors is a 900 micron coated fiber surrounded by a strength member, typically Kevlar, aramid, and then a jacket. Distribution fiber is going to be your lightest, most flexible, and lowest cost fiber. It's great for going long distances. It's great for runs where there's not going to be many terminations at very frequent points. The disadvantage is that you need to terminate this fiber in a protected environment, either a splice enclosure or inside of a panel somewhere. It's never going to move because 900 microns is not a very durable configuration of the product. So we have two choices. Number one, we can either install a breakout kit each point we want to terminate this, and the breakout kit consists of different colored tubings, and they have typically Kevlar inside, so we're sleeving those tubings over each one of the fibers, and then we're able to crimp or terminate a connector easily to each one of these and also use it in a fairly harsh environment. So breakout kit is number one. However, we can buy the cable already made with all of these inner jackets, and that would be called breakout fiber cable. Now, as you can imagine, having these jackets inside is going to substantially increase the size, the weight, and the cost. And you would need to make the decision if it's worth it for you based upon the lengths you're running and based upon the number of termination points you're going to do. So that would be the next question. Now, probably the thing that we deal with, the most common thing we deal with in fiber are patch cords. Patch cords come in thousands of varieties. If you're going to buy patch cords, obviously you need to know, is it single mode, is it multi-mode? Is it simplex or is it duplex? Danny will show you that. What kind of connectors do you want? Are they the same on each end? Are they different? What type of polish do you need in the connectors? Because as you can see here, you've got green plastic housings, which typically is going to designate an APC. And we have a couple of slides on that in just a few minutes. The other thing that many people do not consider in buying patch cords is what diameter is the jacket. Now, that's something that may be in the fine print, and maybe you didn't even think about it before, but there is a big difference. The 1.6 millimeter, which is your thinnest, is okay if you're working with a rack, again, if it's in a protected environment, but it is not going to hold up very well in the field. So usually for a few pennies more, you can get either a 2 millimeter or a 3 millimeter jacket, which is going to hold up much better. One of the subcategories of fiber cable is called tactical fiber. What does tactical mean? Well, it means in reality different things to different people. It means either it complies with a specific mill spec or that it complies with a manufacturer spec under the generic description of tactical. Now, typically in the broadcast world, we manufacture, and many other companies do as well, a broadcast tactical fiber. These are robust, rugged fibers that are made to use outside in harsh environments. They do really well. They are basically the same as the military, but they do not have to meet some of the more stringent testing that may not be of value to us in the broadcast world. Tactical fiber comes in single mode, it comes in multi-mode, it comes in 2, 4, 6, 12, or other fiber counts, and with other variations. So you've got your choice in fiber, but it's tactical fiber is probably the most common type of fiber that we use in outdoor broadcast for good reason. Another subcategory is hybrid cable. Hybrid cable is basically a mix of fiber together with copper. You can have single mode or multi-mode fiber, audio, video, power, Cat 5 or 6, all in one jacket, as you see in this illustration. And then a further division of hybrid cable is stadium cable. Stadium cable are basically multiple channels of SMPTE cable under a single jacket, and these are made to facilitate installation in facilities where there are multiple cameras and you have to move them from the same point A to point B. And there are different variations of SMPTE cable, which again, we'll look at down the road. So now let's take a brief look at connectors. The first group of connectors would be the discrete connectors. We call them discrete because it's one connector going on one fiber. Now, as you'll notice, 2 of them are metallic and 2 of them are plastic. I don't have to tell you that the metallic are going to hold up much, much better, and the plastic are probably not going to do too well if somebody steps on them or a camera runs over them. You better be ready to re-terminate. Another thing you'll notice is that the 3 on the left have a much larger diameter ferrule, that's the protrusion from the front, as compared to the one on the right. If you actually measured those, you would determine that the 3 on the left have a 2.5 millimeter ferrule, whereas the far right, the LC, is half of that, it's 1.25. Why is that important? Because all of the equipment you buy for termination, for testing, for cleaning, is all based upon ferrule size. So if you're using different size ferrules, you're going to need different sets of all of those equipment. The plastic connectors can come in either simplex or duplex. The duplex means there's a plastic clip typically that joins them, and the only issue here is it A to A and B to B, or is it crossed over? If you do get the wrong thing, typically you can just unclip it, switch it, and put it in the right configuration. Another variation of fiber connectors are multi-fiber connectors, or MTP. I like to illustrate the Neutrik version just because it has become a major factor in the broadcast world. You can see that these are either 12 or 24 fiber, either single mode or multi-mode. The great advantage is you're transmitting massive amounts of data over a single small fiber, and it terminates in one of these receptacles that fits in a standard D mount, and then you just buy a fan out in the back that will break out those 12 or 24 fibers to any standard connectors that you need. Now, we talked about polish a minute ago. For some of you who do polish on your own, you know that there are options in the methods we use to polish. For those of you who are thinking of doing polish, please be aware that you can go from very simple with inexpensive tooling with mediocre performance all the way up to your fusion splicers, which have phenomenal performance, but obviously require a bit more training and a bit more investment. Which one is best for you depends upon how often you do termination. Are you doing it in a lab? Are you doing it in the field, and so forth? So now let's take a look inside of a SMPTE cable. A typical SMPTE 311 has got a steel strength member in the middle, 2 single mode fibers, the blue and the yellow, 4 20 gauge copper conductors. Those are the 2 blacks and the 2 whites that we twist together to use as a single white and a single black. And then we've got the data conductors, the 24 gauge red and gray, which now sometimes are necessary and sometimes aren't, depending upon the camera software. Taking a close look at the inside of this is a typical LEMO SMPTE connector, you can see the fibers and the copper, and you can see the strength member cut off of that hex key in the connector for strain relief. Taking a front view of the chassis connectors, again, these are LEMOs, and they're not the only ones available, but they are probably the most common. The ferrule in these connectors is 2 millimeters, so it's not the same as any one of the standard. Then again, we are going to need separate cleaning and testing equipment to adapt to a 2 millimeter ferrule. If you need the SMPTE connectors and you don't have any SMPTE connector cables, you can use adapters that'll terminate these into STs or any other type of connector you use. The panels of today are always consisting of different types of fiber together with copper. This is an example of something that we did a lot of. You can see that there's optical con in the upper left, there's MTP in the upper right, there's your Cat6, there's BNCs, there's STs, XLRs, DT12s, and then LEMO SMPTE cameras, the 1 to 4. This is something you could expect to see in most future facilities. Panels for fiber are available today in literally thousands of configurations. I just like to point out here that it's often more cost effective and space effective to specify what you need for your installation as opposed to just picking something off the shelf. The costing is so close that you can often wind up coming out ahead. I also like to emphasize in panels today, the pigtail design allows you to do modifications, additions, instant maintenance without ever having to terminate a SMPTE connector. Terminating a SMPTE connector is a very training intensive, time intensive, cost intensive procedure, and it's something that you probably don't want to do unless you're going to do a lot of them. So by having pigtails, you can buy replacements, you can keep spares, and you can immediately change them or add them as your needs dictate. Now, if someone is to come to you and say, I need one of those SMPTE cables for my HD camera, please note that the connector on the left is a SMPTE connector. The connector on the right is a SMPTE connector. So which one of these are you going to use? Because there's not going to be a very good success trying to mate these two together. The LEMO on the left as opposed to the Neutrik optical con on the right are both standard SMPTE HD connectors on broadcast cameras today, and you need to know which one it is. There are also all types of adapters. If you do have the wrong one and you need to convert one to the other, you can easily do that by going to STs. Now, another variation of multi-fiber connectors are these hermaphroditics. These are typically found in the military environment, but you will find a lot of them in outdoor broadcast. And these come in really handy after you've run that 700-foot of cable and you realize you should have pulled the male end, but you pulled the female end. With a hermaphroditic, there is no male and female. Every end mates to every other end, and you don't have that issue. However, many of these use a different construction technique called expanded beam. And I just spend a few seconds on it in case you haven't heard of this. All of the connectors we've looked at so far have a direct ferrule to ferrule contact. So there's an extremely efficient transmission of light. Unfortunately, there's an extremely efficient transmission of dirt and damage if it's misaligned or the force is not proper. So some smart engineers came up with this idea of protecting those ferrule ends by using a system of lenses and mirrors. And it's really great in terms of cleaning because all you have to do is dump it in a bucket of water and wipe it off with a rag and it's fine. However, you do pay a big price in terms of size, complexity, termination, and cost and weight. So you don't find expanded beam that often, but you do find it. I spend a minute on the Neutrik optical con family just because it has become so popular in our world, and it is important to have an understanding of what this thing involves. Basically, optical cons come in either fiber only or fiber plus copper. The fiber plus copper is the one you're looking at in this slide, and I'd like to point out you can see there's two contacts in a rectangular opening and there's 4 small holes. Now that's the same connector whether it has copper in it or doesn't have copper in it. So it's really important if you're buying one of these things that you know which one you need, as well as whether it's multi-mode or single mode. There's also a whole other series called the light series, which are made out of plastic, which are good for inside but not good for outside. Some of these advantages, and I'm sure you've seen these things and they're all over the place. The receptacles are standard D mounts. You can easily move them around or change them or add them just by plugging LCs into the back. They also have the feature of the dust shutters you can see on the receptacle and on the connector. These things help, but they are not 100% foolproof in terms of cleaning, and you do have to clean them. Again, there are adapters that allow you to go from these to pretty much any other type of fiber connector you'd want. And then media converters. We like to mention these because this is something that's become a huge part of the broadcast world. You can convert anything from a single video signal, 3G or 12G or so forth, over a single fiber and go for 20 miles, or all the way up to a complete broadcast camera that you can convert every single signal, lens controls, and so forth onto a couple of fibers, bring it 10 miles if you wanted to go that far, and convert it back to the camera again. So there are amazing technologies there. I like to mention materials and specifications of cable. This is something very dear to our heart. Being a manufacturer, we deal with this every day. And as a good engineer, you would look through a catalog and picking a cable, and you know what PVC means, you know what polyurethane means. I like to point out that each one of these names represents a large family of product with widely varying characteristics. We use dozens of different types of compounds. Even though they have the same name, they have different flexibility, they have different temperature ratings, they have different durability ratings, and there are a lot of details if you want to get into the nitty-gritty. But each one of these things has an impact not only on the environmental resistance of the cable, but on the electrical performance as well, critical for us. And following along the same lines, I could not do this presentation without mentioning UL. Now, UL, as you probably know, is an independent test laboratory that certifies that products, and in our case, cables, comply with the National Electric Code. You probably have a copy of that in your office, issued by the NFPA and adopted by most jurisdictions, but not all, in the United States. So this specifies what characteristics cables have to have, what tests they need to pass for you to be allowed to use them in different applications or different facilities. The most common that we deal with in the broadcast world are riser and plenum. There is a huge difference between riser and plenum. To meet a plenum specification, you have to use specific materials which are drastically different in size, flexibility, weight, and cost than materials that we use for other ratings. It is extremely important that in any new facility or even changing out cables in existing facility that you are aware of what the requirements are in your jurisdiction, because we have heard many stories of people not taking the time to do that, spending a huge amount of money and many, many feet of cable and having an inspector show up and say, take it out, and you have to. We'll be happy to discuss any UL considerations with you later. You saw in the video a couple of seconds of braiding, and this is just to illustrate one aspect of the manufacturing process that is relatively low tech, that people take for granted, but one change in braiding will impact many different areas of performance of the cable. And even though we have fiber optic SMPTE cable, that's true, but there's copper in it, and in most cases there's a braid on it. And in many cases we're using that braid for a ground. So you've got a picture here of a 24 carrier braider. There are bobbins going in opposite directions at a relatively high rate of speed. Each one of those bobbins has 11 strands of a 38 gauge wire. So there's 200 and something wires that have to cross at exactly the right angle, at exactly the right speed, and anything that we do to change that is going to change not only the percentage of coverage, which is the number that people typically look at, which is only half the picture, but it's going to change the DCR, it's going to change the weight, it's going to change the flexibility and the size, and obviously the cost. So something that simple has that much of an impact. Danny's going to show you some termination and troubleshooting techniques, but basically I like to illustrate that all of these tools depend upon what you're doing with them in terms of, do you justify spending or making the investment in some of these pieces of equipment? Are you doing enough terminations, and what type of terminations? In your choices of polish, there are two that are pretty common and one that used to be common, but you may still see around. So a PC polish is the old polish. You'll find them in closets in different places, but nobody's going to pick a PC polish for anything new today. The UPC is going to be your most common, and if nobody says anything, it's probably a UPC. UPC at 50 to 55 dB of reflection. Again, coming from the RF world, that's a pretty good number, but if that's not good enough, APC is going to give you 15 to 20 dB more. We get the APC by actually cutting the fiber at an angle, and that's improving the performance. You saw in the slide with the patch cords that those APC connectors had green plastic. That's usually an indication, but it is not a guarantee that they're APC polish. If you do need connectors with APC polish or cables pre-terminated with APC polish, bear in mind that you need to mate them with other APCs. You don't mate a normal with a standard. Fusion splicers are phenomenal pieces of equipment available in many, many different options. I just like to point out that the fusion splicer, depending upon what you are doing with it, whether you're splicing on connectors, whether you're doing cable-to-cable splice repairs in the field, the adapters and fittings and holders and accessories can often be as expensive as the machine. So please look at the whole package before you go out and buy one of these things. We mentioned the core and the cladding, and this slide is illustrating what it actually looks like. If you haven't had the pleasure of doing this, you've got the 900 micron, which is the blue coating, you can see, and the 125 micron cladding over the glass. We would not be able to see the actual core. This is the smallest that we can see without a visual aid, and that's going into a F2 contact, which is one of the SMPTE contacts. Danny's going to give you a great illustration of troubleshooting and the interferometer demo, but this just illustrates that the geometry is just as important as the dimensions. The angles all have to be right, as well as the dimensions, and when you're dealing with millionths of a meter, the smallest error is going to create sometimes major signal issues. These are some of the things that we see. We repair cables every day. I think we've seen all the mistakes. We thought we did till last month. We saw something and couldn't believe it. That was new. But basically, these are some of the things that if you're doing your troubleshooting, you may encounter, whether they're issues with termination or whether they're issues with damage in the field. So you can see these are some of the standard things. I have to emphasize that the biggest three issues we find are dirt, dirt, and dirt. So please keep your connectors clean. We recommend that you clean a connector every single time you connect it or disconnect it, as well as keeping it covered with a boot or other similar protection whenever it's not in use. Now, anybody who works with fiber must have cleaning supplies. If you don't, you should. There are many different cleaning supplies available depending upon what your particular needs are. The click pens, and Danny will demonstrate one, are a really, really great option. They come in different pens for different ferrule sizes, and they do a really good job. The same considerations apply to test equipment. You can get something for $100 if you want to just know if there's light coming down a fiber, or you can spend tens of thousands and get something sophisticated. We'll show you a few different options, but you should have the equipment that is suitable for what you're doing with it. How critical is it that you need to diagnose something on a Saturday night at 2 in the morning, or can it wait until you send it off to somebody? So that'll determine what type of equipment you need. We've tried to demonstrate how over the years the data rates getting higher, the bandwidths getting higher, have required higher and higher performance from cable. Now, we believe, and we manufacture a lot of cable, a lot of people do, we believe that copper is always going to have some place in our world, but the place that it has in our world is far less than what it was before, and I think far less than what it will be in the future. So we're looking at standards, SMPTE standard 2082.11, 24 gigabits per second. So what you can do with copper is going to be severely limited, whereas with fiber, the sky is the limit. So with that, I will turn the presentation over to Danny, and he will be happy to answer any questions you have and show you some really cool stuff.
Howdy, everybody. I think you have to turn yours off for me to go full screen. There we go. We're using something different today. I have no idea what just happened. There we go. Bear with me a moment. This is a new piece of software that we're using today, and I'm not as familiar with it. Hopefully everybody can hear me, and everybody can see me. My name is Danny. I've been doing this a long, long time, like all my life, and long before actually we instituted any fiber and broadcast. I'm an old RF head, satellite, 2A radio, that kind of stuff, power amplifiers, but you know, we grew into the fiber. I'm going to be very remedial. I'm going to take a couple of steps back and talk about common problems that we run into in purchasing mostly. When you designate people to go acquire something for you, or you quickly try to acquire it on your own, you pick up the phone, you ask for something. The most important thing is asking for the right thing, because if you're in a hurry, you don't want 400 of the wrong item to show up. And I can tell you this happens all the time and over again. The variety is endless. So I'm going to face the camera down and show you with my hands more of a show and tell approach to this. So, all right, what we have here is fiber, 3mm jacketed fiber. And to be remedial, one of the biggest problems we had with people calling up and asking for a patch cord is we ask them whether it's single mode or multi-mode. And they say duplex. And, or they may say simplex. And we have to explain to them that duplex is literally just two. Simplex is just one. Unfortunately, I don't expect purchasing people to know this, but you need to spell it out for them, either written or otherwise, that duplex, simplex don't actually tell us anything about multi-mode or single mode. In the single mode world, there's really only one flavor. In the multi-mode world, we've evolved into different flavors, but OM3 on, you're going to be okay. OM1 was the only crazy one in the transition, in OM2, that was a little crazy. That was 62.5, but we're pretty much strictly 50 micron. 9 micron being our single mode, and broadcast is predominantly single mode. I would never design around multi-mode. I don't suggest you either. It'll get you in trouble. The other thing I'd like to talk about is connectors. Connectors get a lot of people in trouble when they call and order different types of patch cords. I'm going to show you a few different connectors here and tell you the problem we run into them when people call us up on the phone and say they'd like to order a patch cord. First they say they would like a patch cord, and they don't say whether it's single mode or multi-mode. And after we've squared that away, we say what kind of connectors, and they say STs. And we go, you mean a Sam Tom? And they become a little concerned. Well, the reason we say that is we say everything phonetically, because I've shipped hundreds of patch cords to people for them to turn around and go, that's not what I want. So I insist that you give it to me phonetically. Sam Tom, which is the most common bayonet locking field connector. Frank Charlie, which is a FC, which is a threaded connector. You'll only see this with like satellite uplink, downlink, and RF transceivers. Lima Charlie, the LC, and Sam Charlie, its big brother. If you don't say these phonetically, I'm sorry, but ST, FC, LC, and SC, and LC, and SC all sound alike to me. SC, FC, and LC pretty much all sound alike. It's imperative that you say these phonetically, and I would suggest you never verbally give that to a purchasing person, that you insist also with them, and they write it out. Because if they order 500 custom-made patch cords with the wrong connector on them, you're going to eat them, and you don't want to do that. The other thing with patch cords is diameter of glass. If you're in a 96 position patch bay, you're going to have 96 duplex cables side by side. 1.8 to 2 millimeter in diameter is probably what you want to go with. But if you're going to make a patch cord that's going to go from a media cart to a wall for a disconnect, and people are going to actually plug it and unplug it routinely, you're better off with a 3 millimeter in diameter. Commonly, patch cords are just standard PVC. They're not tactical. You can purchase custom tactical patch cords, but that's not your bread and butter. So, knowing what diameter you would like and why you would like it, I would not use a 1.8 millimeter diameter fiber, jacketed fiber, in the field. It's not going to last a minute if it gets slammed or caught on anything. Whereas a 3 millimeter is going to hold up much better. Now, knowing what you want is very important. And knowing how or its application, where you intend to use it. That's really up to the engineering staff, not up to purchasing. The other thing I'd like to do is show you distribution, like you mentioned. Those are all sort of breakout because they're all their own jacket. Distribution glass actually has one overall jacket with very small pieces of fiber. In this case, this is OM3, The color, aqua in this case, is indicative of the type of fiber. And inside of this particular fiber, and this is only 3 millimeters in diameter, we have 4 pieces of glass. While in these style jackets, there's only 1 piece of glass. In this case, you can have, believe it or not, I've actually seen 12 fibers in one 3 millimeter jacket. But this is 250 micron jacketed glass. This doesn't belong anywhere other than inside of a box. You can also purchase it as 900 micron. In this case, this is a tactical breakout. The 900 micron glass, of course, is literally almost 4 times the size of the 250 micron. This is fairly easy to dress, and I'm actually going to illustrate that because I think it's imperative that everybody have some hands-on experience with glass termination, especially field or tactical breakout. The TAC 4 is what I'm going to use for illustrative purposes. It's about 6 millimeters in diameter. This is a homebrew style breakout. This is nothing more than double wall or insulated heat shrink, and it has been broken out, meaning the individual pieces of glass have been covered, much like you would do with heat shrink, but they've been covered with something called furcation tubing. Furcation tubing is unique to the fiber world. It's basically an overall PVC jacket with inner yarn and an inner piece of poly tube that the 900 micron or 250 micron glass slides through. This gives you the ability to take a tactical cable, which is a polyurethane jacket with built-up yarn. It can be Kevlar, it can be Aramet, I'm going to refer to as yarn, and then 900 micron, and break that out to individual connectors for field use. I'm actually going to quickly illustrate that and show you what tools are involved. This is actually a 3 millimeter TAC 1. The reason it's tactical is because it is a polyurethane jacket and it has yarn inside of it that's basically bonded to the internal jacket. This has, in a slow pull, almost 1,200 pounds of tensile. I kid you not. You can tie this stuff in a knot and you can pull it pretty damn hard. It is extremely durable, but I would not consider it a common patch cord for racking. A connector I'd like to show you is the ST. The ST is most common to the field connector. You'll find that in your stadiums and your patch bays at field venues. Not as common as on your BSPs, but it is the one that is most like a BNC connector. It comes in 3 pieces: a boot, a crimp sleeve, and a body. In order to terminate it in a tactical fashion, we would use a 2-part epoxy. We choose a 5-minute cook, 110C 2-part epoxy that's pre-mixed and installed in the syringe. The boot is slid onto the cable first. The crimp sleeve is slid on second. It's a stepped ferrule, which is common to small cables in the RF world as well. Now you can look up the manufacturer and write out or use a ruler to specify dimensions of the strip, but I'm going to tell you, if you just learn to eyeball it, you'll be fine. It is a 3-stage strip, just like a coaxial BNC. You would first remove the jacket material to expose the glass and the yarn, and it would have to be longer than the entire length of the connector plus some. So I'm going to do that first. First thing I'm going to use is a pair of strippers. This is a 3-die stripper, very inexpensive, and I'm going to remove the jacket. Because this is a tactical jacket, I have to pull it off in small pieces, so I'm nibbling it, as you can see. I can't strip it all at one time, like you would a PVC jacket. As you can see, I've removed the jacket to expose the yarn longer than the length of the connector body. Next, I'm going to pare off the yarn and cut it back as if it were a BNC by cutting it down so that it reflects a braid of a BNC that would be attached to the butt of the connector. And as you can see here, the yellow, the 900 micron, is much longer the connector. I'm going to remove the jacket of the 900 micron to the base of the zirconium so that the butt of the connector and the jacket are occurring at exactly the same time, just like a BNC. The yarn will be crimped to the base of the connector. The jacket is removed when it reaches the zirconium, because only the 9 micron glass, well actually it's 125 micron with the buildup, will go through the zirconium. Now, the strip is again with the same tool, and it's nibble because this is a tactical jacket internal to this. I have to take it off in small pieces. If this was PVC or one of those inexpensive Chinese patch cords, I could probably remove larger pieces of it. Now that I've removed the 900 micron buildup internally, you can see, I think, the 125 micron core. And there's still some residue on it that I have to remove with the last and final dye of that. Now I'm going to use a little bit of alcohol, and it is literally just alcohol, and a chem wipe, which is nothing more than a lint-free wipe, and remove the residue from the core of the connector. So basically I've got a 3-stage strip that aligns with the connector body. It's strictly an eyeball technique. Now, normally I would pre-mix my epoxy. Like I said, it's a 5-minute cook, 2-part epoxy. We usually stick it in a syringe. In this case, I'm using a little bit of alcohol because you can't dry run glass in a connector without risking breaking it. But I put a little bit of alcohol in here to simulate the epoxy. So we would squirt a little bit of the epoxy up inside the connector, flare out the yarn because it's basically mimicking BNC or braid, and then I'm going to slowly work the glass up through the connector like so. And in this case, I need to strip a little bit more. I need the butt of the connector to be flush. So, now I'm going to bring it up inside, a little wiggle if it binds. Okay, so the yarn is basically our braid, and we're going to slide our stepped ferrule up to the butt of the connector, sliding it all the way up. Don't worry that you see a little excess of yarn. The boot will actually push that up inside with this particular brand. I'm fond of this manufacturer, Senko, by the way. Now, basic crimp tool, interchangeable die system, inexpensive tool, inexpensive die system. In this case, it's going to crimp 178, which is the common crimp for like your miniature videos, your Belden 1855s and whatnot. So the large portion of that will crimp at 178. Now this is a stepped ferrule. In the back of it's going to grab the jacket. In that case, it's 151, which is not common to the RF world or to the coax world. But like I said, it's an inexpensive die and an inexpensive crimp tool. So 2 steps. We've grabbed the yarn. We've grabbed the jacket. Now we're going to slide the boot up. It goes snap. It actually pushes the excess of yarn that you saw out of the way. Next, we would drop this into an oven. Inexpensive multi-position oven. That oven is no bigger than this box of chem wipes, about the size, twice the size of your fist. It will cook for 5 minutes at 110 C. We will pull it out and we will let it sit until it cools off. After it's cooled off, we will simply remove this inexpensive protection sleeve that is made of plastic, and you can buy them 100 at a time. Hopefully the camera can show you here a piece of glass protruding past there, the 125 micron. So at this point, you would need a scribe. You can buy scribes in diamond, sapphire, all kinds of craziness. This is just carbide, just plain old carbide. You would basically score the glass at the base and tap it. So you would tap it into a catch or a double adhesive area so that you can keep track of your broken glass. Now you've got a tiny little burr of glass on top. Now, you can either invest in a large bench mount polisher, or I'm going to show you a basic polishing technique by hand. I can do this, and I still do this regularly. These are pads from my base polisher. They're 90 durometer. The film that's on here is 15 micron silicon carbide. Basically, it's a dry film. And as you can see from the scoring on it, it is used just to reduce the epoxy that normally appears on the tip of the connector and the glass. You can use a basic puck. This is a universal puck for 2.5 millimeter, which is the diameter of that ferrule. And I'm going to quickly do some figure eights, 8 to 10 passes, and voila, I have reduced the epoxy and the glass, the burr on the glass, to the surface of the zirconium. Then I would switch to, this is another 90 durometer rubber pad. You can get them in squares, rounds, whatnot. I'm a big fan of 90 durometer. It does what I need it to do and doesn't pencil tip my contacts, tends to flat polish them properly. In this case, this is a diamond film. When I hand polish, I actually use the 4 stages of film. That's counting the 15 micron. This will yield you 25 to 30 dB of back reflection, which is very respectable for a field cable when it's point to point. Ideally, you would want UPC machine polishing, but that is when we're talking 4 to 6, 8, 12, 24 connectors in line. Most field connections, there's only 2, 3 jumpers involved in it before it's reclocked or it's device to device. Most of your media converters, most of your hookups on your I/O of your trucks, or your I/O at the truck dock, or the output at your portable cases. In this case, like I said, diamond film is my preference. You can also get this in aluminum oxide, which is an inexpensive film. I spend the money, I buy the $5 diamond films. I get hundreds and hundreds of uses out of it. Water is your only lubricant, and the same thing. Simply figure eighting. 8 to 10 passes, you'll pass between, in my case, my preferred polishing technique is 15 micron, and then I use diamond film, and I go from a 6 to a 1 to a half. The half is a weird, unusual thing, but it beats trying to go to an ultra film. If you want, you can skip the half and go straight to an ultra film, but it's completely unnecessary because you are hand polishing. This will yield you a tactical cable on a breakout design, 4 positions. You're going to spend about 10 minutes a connector. And actually be able to service, maintenance, or build your own tactical cables. I believe this is important that every shop be able to do this that has remote trucks. You can't keep sending me your TAC-12s unless you insist that I repair them. Being able to maintenance these is important. None of the tools I've shown you are expensive. Matter of fact, they cost no more than doing conventional terminations in the coax world. It isn't until we actually need to test or visually inspect the connector tip that we're actually going to spend any money, and that's where the budget needs to be set aside for. In this case, a video scope. Video scopes, in my opinion, are no longer a luxury, they're a necessity. A video scope gives you the ability to plug the connector in the end, and in my case, it's plugged into a laptop. I get to look at a big, bright image. I get to look at the quality of polish. I get to clean my contacts. In addition to that, because the contacts inside of multi-pin connectors, hybrids, such as the Limo SMPTE, those contacts are embedded down inside the connector. You don't get to go there and get to them, as in the case of the Limo, with a conventional handheld scope. Conventional handheld scopes do serve a purpose, okay? In this case, this is a very strange multi-position scope. It's part of a kit that Neutrik provides. But you won't be able to reach down inside the Limo connector to actually visually inspect it. So owning the video scope is imperative. Plus, it gives you the ability to properly inspect your cables for dirt. And dirt is the #1 cause of all your problems. I believe your best approach to any type of maintenance is to clean it before you use it and clean it after you've used it and put it away. I wish everybody did that. So owning a video scope is imperative, in my opinion. It comes with lots of different tips to be able to plug into many different types of connectors, whether they're receptacle-based or exposed ferrule designs. So I'm going to quickly show you a input. Now, this is different software, so bear with me. I got to bounce in between my camera inputs. So stop sharing, hide preferences, hide preferences. There we go. Okay, so now with the video scope, I'm going to basically plug a connector in and show you the surface area of a contact. Okay, a little bit of grime there. Let me wipe that down real quick. That is a polished connector. It's one I use regularly, so it might be a little scuffed up. The tiny little dot in the middle is your business end. That is your 9 micron. The rest of that's 125 micron core plus epoxy. The white stuff on the outside is the zirconium. So as you can tell, it don't take much to mess that up because it is a very small aperture. So I'm going to switch back to my other one, and it requires 2 steps to get there. Okay. Contacts are always positively engaged. Other than expanded beam, contacts are all mashed together. There's some people out there that always thought that contacts were spaced apart inside of alignment sleeves. That is a fallacy. Alignment sleeves, they are not. They're actually mashed together. So they are 2 contacts that are mashed together under spring-loaded pressure. So anything that's on one is immediately transferred to the other. So I'm going to simply touch the surface of this contact, and I'm going to plug it back in and switch to the camera inputs and show you why you need to own one of these or be able to maintenance properly because of that. Just touching the surface of the contact. Now, I was very fortunate that we have no large pieces across my core. I'm assuming that's just dead flesh. This thing is blown up huge on my screen. That I don't have some huge piece of dead flesh across my core. Had I had that, it would have probably cost me 6 to 20 dB of attenuation. So, bouncing back, and of course it takes 2 steps to do this. Come on. Okay, so cleaning this. There are several manufacturers make several different types of cleaning things. Stickler does a good job of good quality, fast accelerated, alcohol that basically evaporates. It's very similar to lens cleaner. I'm sure some of you are familiar with lens cleaner. But the greatest invention are pens. These one-click pens are basically using string. Inside, there's a bobbin of string. The string is going to be pulled across the surface of the contact, okay, like dental floss. And it is aligned through a tip. And they come in all different sizes. And in this case, I'm holding 3 in my hand. And yes, you must have 3. So you've got your LC, which is your 1.25. That's Lima Charlie. Then you've got your SC, ST, FC, Frank, Charlie, Sam, Tom, etc., etc. That's your 2.5 millimeter. Then you got your 2 millimeter. That's your SMPTE. You need to own, all of them basically in order to service a maintenance fiber. So I'm going to illustrate. Basically, you plug it in, snap, snap, and then I'm going to show you what it's done with a snap. Remember, 2 steps to get back to my camera. Okay, so as you can see there, I wiped out 99% of the junk. I wouldn't call that a perfect clean. I could snap it a couple of more times. I could actually switch over to some Chem wipes and wipe it down. Or I could choose to use a different type of cleaner. I'm going to quickly show you one of those because, like I said, the #1 problem you're ever going to experience is dirt. Regular maintenance of this is important. So Stickler, and I'm not trying to peddle Stickler over any other one. I'm just extremely fond of these particular things. Think about this as a reverse Q-tip design. We have a full synthetic material that's up inside of a poly tube that gives me the ability to press against the surface of the zirconium and rotate, and always rotate one direction. You basically want to move the dirt from the core, the center core, away to the outer perimeter. In addition to that, because this material is compressed inside of this poly tube, when you press it, it folds apart, and then as you release it or pull it away, it actually will lift the garbage off the end. But the poly tube allows you to reach inside of connectors, which is advantageous. So let's move to cleaning a SMPTE, a LIMO connector. The boy has the alignment sleeves, or the plug, the camera end. Just remember, it's the opposite of triax, and you'll get it right all the time. The girl, the jack, has exposed contacts. Reaching inside to clean those is very, very simple. Reaching inside to clean those with a pen, very simple. Simply align them over the top of it and snap. Now, The plug, having the alignment sleeves, would require that you own a special tool to remove that alignment sleeve. That actually exists with every connector, whether it's a mil-tack or multi-pin connector. You have to own something to remove alignment sleeves. In this case, it's relatively inexpensive. The inside of the alignment sleeve is threaded. This is a threaded tool. It simply goes down over the alignment sleeve. You thread it on 3 or 4 threads and you're good, and you pull. You've extracted the alignment sleeve. That is the alignment sleeve. Threaded on one end, and that's the end that you use for extracting. Don't put it in backwards. Okay. These things do break. Owning a few of them, half dozen of them, will save you a lot of headache. Inside of an alignment sleeve, all alignment sleeves, is a C-shaped piece of zirconium. It basically flexes a little bit as it allows 2 contacts to align under pressure. Dirty contacts may cause this to break prematurely. A broken piece of zirconium inside of a alignment sleeve is good for 20 dB of attenuation. I kid you not, those 2 contacts won't even come close to aligning. They will be so offset, you will assume that your cable is broken, when in reality, it was a $10 alignment sleeve and a $30 tool that all you needed to own to install and uninstall that alignment sleeve. So again, extracting the contact threaded or alignment sleeve, threaded on, pull. There you've got your alignment sleeve in your hand. Now you'd have the advantage. You can use a one-click cleaner, snap, snap, to clean the contact. You can switch over to the tip that is made specifically for 2 millimeter contacts, reaching down inside the connector, visually inspecting it. So, or you could use the stickler, sort of the reverse Q-tip design. I call it a 25. It's part of a color code matching system, so where all the different ones are different colors. So, and they come in several different kit forms. So, or just reach down inside and again, rotate, 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 rotate. So, you'll probably end up using something like this. If you have dirt, you'll actually have to use a little bit of alcohol and go wet, dry, wet, dry, wet, dry, several cleans. Your cameras need a lot of cleaning, I can assure you. If you owned one of these and you visually inspected the receptacle that's on your camera, you would be amazed at the amount of garbage that is, the amount of attenuation that you're experiencing just on your camera ports. So after you've cleaned it, to reinsert it, you simply thread it back onto the tool. You reach in, press till it snaps, unthread the tool, voila, you're done. I want to quickly show you something unique about the LEMO and the fact that I can also swap heads on this. And quick breakdown of the connector. If you end up with a patching system where the panel mount connector is actually mounted inside, it was usually mounted from the front. It is much like the triax connector, cannot be mounted from the rear as it has moving parts. So being able to disassemble this connector and reassemble it without losing the parts is to me very important. There is 3 pieces to this connector. There is a back nut. There's an intermediate male-female body. In order for you to properly disassemble this connector, you need a very, very thin 15 millimeter wrench. These have been ground down. You can purchase on the web very, very thin wrenches. So, or you could grind your own down, 15 millimeters. Now basically, back this up, and they're always going to be Loctite. So expect to find a little bit of Loctite, preferably blue. It is a steel-on-steel connection, no set screws. So we've extracted those 2 particular pieces. Now, there is a clamshell here, so I suggest you hold it. Then you can remove the head. You have an insulator here and a clamshell. And you would prefer that they don't come apart as they may become confusing to you unless you are used to taking these apart. At this point, you can actually pass this through a panel and install the panel mount head, which I thought I had one readily available to illustrate this, and I don't. But reinstalling the head, there is a polarizing tab there, raised, and there is a cutaway there. They simply line up. If you have not allowed the clamshell to come apart in 2 pieces and confuse you on reassembly, that is all that's involved, is aligning that up. It should be flush with the threads. You would bring this part back up, thread, 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 thread. A couple of pounds of torque, and then you would bring the back nut up, a couple of pounds of torque there, and it will be required that you hold the first one to tighten the second one. So, and then, again, the same thing. 15 millimeter, very, very thin wrenches. Tight, you are done. That is all it's taken to assemble and disassemble one of those. Now, LEMO is not the only game in town. Neutrik is also involved in this. Neutrik is unique in the fact that there are only plugs. There are no jacks. This may change with the new Dragonfly connector, which is an expanded beam version of the connector. It doesn't exist on any equipment, so I'm not going to go into it. But the Neutrik SMPTE, which is important that you know the difference. If you buy the cameras, find out what you bought. Make sure they match your studio. Don't buy Sony cameras that come with Neutrik connectors if you just wired your infrastructure with LEMOs, as you will have to buy some very expensive adapters. This has happened on a few occasions. Okay, the Neutrik connector, the contacts are basically LEMO Charlies. They're LC connectors. They're down inside a shuttered mechanism. There's a pair of them down there. You have to get access to them to clean them. Neutrik does make a small retainer adapter that will actually retract this, just like you saw me do, by pressing this down to expose the two contacts. It basically snaps on and gives you a tube. Now, what you do with that tube, well, you have to stick a one-click cleaner in that you've removed the tip from, that basically only has the smaller portion that goes down inside, snap, snap. Or you could use specialty stickler tubes that were actually made to go through small alignment sleeves for LCs. That's one approach. Another approach is if you don't own this, because this is proprietary to this connector, is learn to take this connector apart. I've had repairs come to me with channel lock marks and vice grip marks because somebody didn't know that in order to take this connector apart, you have to retract this spring to move this wavy washer, the slotted washer, away from the back nut. Why? Because the back nut has teeth, raised teeth on it. So those teeth will stop you from unthreading this back nut. So once you've unthreaded the back nut, after you've retracted that washer and that spring, if you keep the connector top dead center, that's where the name is, you simply pull the head off. Now you have access to two LC contacts. They're exposed contacts. You can go back to the one-click cleaner approach, snap, snap. You could use my universal I love you tool, reverse Q-tip, rub on it. Chem wipes, alcohol, anything to clean your tips. But most importantly is the ability to visually inspect them. Like I said, you can buy a kit that comes with a video scope that was specially engineered to be able to visually inspect them while in the connector. There's actually a cutaway. This particular tool is on back order, but I think in the long term, a video scope is a better investment for visually inspecting. That's just my opinion. Now, reassembly is just the opposite. If you kept track of the connector, the large polarizing tab on top, you will see there's a large keyway here, name on top. You simply put it back on till the bottom's out, slide this up. You don't have to retract the washer, and you'll hear a couple of clicks. Those clicks are the teeth running across the wavy washer back here. So once it's stopped, you want to back it up to make sure that it's not putting any undue pressure on the spring. Why? Because the Neutrik is a very short stroke locking mechanism. So, and you want to verify that it does lock, not just throw this back out in the field. I've had instances where people reinstalled them and they weren't seating properly. They sent the cables out in the field and everybody went into panic mode because they could not get them to mate. So they need to disassemble it, reassemble it till it worked. So, verifying that it locks before it walks out the door. The receptacle you're going to find on your cameras and on your CCUs because there is no jack. It is nothing more than a pair of LCs in the rear with some electricals attached. The equipment that I personally taken apart, I was able to pull the two screws off and goose the cable forward just enough to be able to extract those contacts. I was able to service those contacts. The other option is to retract that insert and try to work through alignment sleeves. I'm not a big fan of sticking Q-tips or other type of debris through alignment sleeves if I can help it. I would prefer to actually work the surface of the contact and reinstall them. Keep in mind that this is an AB, while The SMPTE variation of the LEMO is an AA. That's a 1-to-1 ratio on the fiber contacts. The Neutrik is AB, so polarity is everything here. So if you pull this out, make sure you put it back into its position. And they are standard LCs. They don't have a clip, nor should they. It's recommended from the manufacturer that you remove any clips that hold them together, so that it's imperative that you pull A out of A position and put it back after you're done. So the Neutrik is also available in a quad all the way up to an MPO MPT. I use MPO and MPT interchangeably. That's Q-tip and cotton swab. So the quad variation looks a little funky in the end. Okay, blue designates single mode, by the way, and black is multi-mode. Green being APC, very rare, but it does exist. Quad comes apart the same way. Quad is a receptacle that basically has 4 LCs, 2 at the top, 2 at the bottom. So, but in order to clean this baby, same way. You'd have to shutter it back. You'd have to own another fixture for the quad and work through it, or the exact same technique, just learn. And this is also a glass-only connector. So 4 pieces of glass inside. It's crimped and epoxied to attack 4. You can work those 4 contacts, visually inspect them, reassemble large notch, large way, bottom it out, move your back nut up, rotate it, snap, snap, snap. Beautiful. Oh. Now, there are also expanded beam. I'm just going to quickly illustrate one. Expanded beam is selective in where it belongs. It belongs in a high dirt environment where you really need to just spray the contacts down. They're hermaphroditic. They plug end to end. FEMA's made large investments in this kind of stuff. Our government and our military have done this. Sometimes people refer to it as the Navy SEAL connectors and whatnot. But they are basically lenses. There's 4 of them here, and even though this is 2 fiber, there's 4 terminated, or 4 lenses. There's only 2 pieces of glass terminated inside. And they actually mate to each other. You can retract that and plug boy to girl. They're hermaphroditic. They're wonderful when they're left alone. If they're seated properly, plugged in beautifully, and laid on the ground, fine. But I can personally attest to they don't like to get stepped on during live broadcast. During the flexing and unflexing of this, because it's 2 pieces of light that are spaced from one another and shining at each other's lens, any type of heavy flexing of these 2 mated, whether it be to the receptacle or 2, and I was at a golf show, 2 of them get run over, complete dropout. I mean 15, 20 dB of flexing while they get run over by golf carts. So it has an application, but it is a rather pricey investment. Oh. The next thing I'd like to discuss, or last thing I'd like to discuss, I found my receptacle. That's the plug that I meant that I could just swap on, so you can turn an inline buoy into a panel mount buoy. Is an interferometer. Interferometer is a very small box. This thing right here, it's no bigger than a loaf of bread and costs as much as a new car. Not an exaggeration. The interferometer, I'm going to switch over and share a different screen, gives me the ability to inspect the radius of a contact. The F2 contact, or SMPTE contact in the LEMO, is radius, very much like a ballpoint pen. Has curvature, heavily spring-loaded, and in order for us to verify that we're actually machine polishing it, besides testing performance, we actually need to verify that we're actually shaping the glass and shaping the zirconium to meet an industry standard. Why? Because there are 2 connectors that are jammed together. When I say jammed together, I mean they're jammed together. That's how we made these things. We jam them together. So inside, I have 2 fiber contacts that hopefully are clean that are getting jammed together. If one of them is shaped more like a pencil and the other one is shaped more like a ballpoint pen, that means I'm putting undue stress. And I'm going to show you that, and this is the only way you would actually know it, is to own an interferometer, because we're examining things at 1/100th of 1 millionth. So I'm going to try and switch over to that input because it's actually plugged into a different device, and share that with you now. If I can't seem to do it on my own, I would appreciate some assistance. Screen sharing, Henry. Okay, let me try dropping this. Okay. I don't have the option to screen share.
Yeah,
Henry.
I'm looking at it now. Stand by.
Can you bring me up or no?
I'm looking. Stand by.
Okay, it gave me an option, said show my screen. So hopefully it's going to pop. Okay, what we've done here is we've blown up the contact. It's actually showing you the surface of the contact. Now, that is the glass that is crossed there. It's giving us a measurement of the radius of the glass and of the ferrule. And we're talking, it's measuring in 1/100 of 1 millionths. The SMPTE interface, the LEMO interface, is actually a industry standard for 2mm contacts for the curvature of the glass and the curvature of the zirconium. This angle is important that it be maintained. It will actually, under multiple mating cycles, cause damage to another connector. We call them Rudolphs. That's when two contacts have been engaged several times, where one is actually physically beating on the surface of the other piece of glass until that piece of glass sort of gives up or backs up in the zirconium. By doing so, it will cause it to radiate with visible light. If I put a 650 nanometer laser pin in it, it will radiate a great deal of light all around the zirconium area. Now, don't think it only does that because it's broken. It actually could do that with dirt. So a good source of quick diagnostic is a laser pin, 650 nanometer, to show you whether or not you have dirt buildup or your contact is basically broken. The contact has been damaged by repeated use mates or by another contact that was improperly polished. You don't need to own one of these. It's imperative that we own one to proof the polishing technique meets the Telecordia standard. But I think it's a unique thing to show you, as you're never really going to see one again unless you actually, get into the industry of polishing fiber contacts and meeting manufacturer standards. I'm going to go ahead and ditch this video input, go back to my face, and see if anybody has any questions. I know I've been a little long-winded. And trying to figure out how to do that. There I am.
Thanks, Danny.
Howdy. So, if anybody has any questions?
That was great. I have a couple, if anybody wants to post any for me. So one was, so when I looked into doing the SMPTE connectors, I realized I had to spend $30,000 to start. I was curious, how long does it take you to typically put on a SMPTE connector, the 311?
Start to finish, if you do them in like lots of 10, set up with prep, you get a completely different animal if you sit down and try to prep one connector. One connector is going to take you 2 hours, 2.5 hours, one connector. If you do them in lots of 10, you're going to average about an hour, 15 minutes, an hour and a half to put one connector on.
Okay. Second question is, you mentioned the sticklers. I was curious, I've worked with people that have, just for doing lots of LC, have used the clay tops. What do you think of those?
The what?
The clay top, where you just opens the little door and you slide the LC across it.
Oh, no, I'm fine with that. That is, okay, Stickler actually does very similar. It's not a wiping system. They're individual wipes. It's the same material, exactly the same.
Okay.
I'm good with that. But unfortunately, that ain't going to work inside of a connector where the contacts are recessed. That's sort of the drag. A lot of people can't get access to the, did I just freeze? Can't get access to the rear. of a panel to unplug it to work the surface of it, though it would be advantageous to do so in a lot of cases.
Yep.
No, I'm all good with that. But I pushed this particular one for the ability to reach down inside. And they've got
Yes.
innies and outies. In other words, besides being inside of or a cleaner, it's embedded in plastic. It's external to the plastic. It's available to actually go through the alignment sleeve. I'm not a big fan of going through alignment sleeves unless that's the only way you can get to the surface of the zirconium. Why? Because you're always putting that C-shaped piece of zirconium at risk. And like I said, when it breaks, it's good for 10 to 20 dB of attenuation. The glass no longer aligns.
Okay.
I wasn't exaggerating when I said that little $10 part is going to look like a broken connector. It is. You're going to come back here and I'm going to go, okay, I just snap another one on. So.
Okay. And one more thing, the stickler, is that only good for one connector and you're done? Throw it away?
If you were working an installation for IT department or what we call a fiber highway, where you were going to make things once and never make them again. Am I breaking up? Because I look at my monitor and it looks like I'm breaking
You're okay.
I would say yes, but I use them repeatedly because I'm using them on dirty cables. In other words, I am taking a cable that was sent to me or returned to me for maintenance, and I visually inspect it, and I know that I have to scrub the crap off of it. So I will get 5 or 6 uses out of it before it starts putting its own dirt back on.
Okay.
But if I was going to clean
makes sense.
something and marry it and leave it alone, I can take you to several installations where they want to they have a disconnect there, but they don't ever really intend to patch anything. It's just a disconnect at that point. They want to plug it in, and it's going to stay plugged in. They will clean it and throw it away. Why? Because they don't intend to move on to the next one, and everything that they got is really, really clean. It's the first time they've taken the cap off. So before they made it, they want to visually inspect it. And believe it or not, I get dirt out of caps all the time. They're protectors. They're not dust caps. They don't keep any dust out. And half the time, they were left out, and they got crap in them, and you put them on and put it on the tip of a contact. It is quite amusing that I have brand new connectors I've tipped, and I grabbed some caps, and I put them on, and I just munged them all up, and I got to go back and clean them all myself. So I'll get several uses out of it because I'm using it with used cables. But if you're working brand new stuff that you plan to plug in and leave alone, then yeah, throw them away like Q-tips.
Okay. One more question is the video scope. So, I've done SMPTE where I cleaned it with the punch down tool, but I have a microscope, but I don't have the video scope. I understand they're about $1,000 or so. Is that something that a company like your company sells, or where does someone buy those?
Yes, we sell it. Lots of distributors sell it.
Okay.
You'll notice I didn't pitch any one particular thing to say we're sole proprietor of anything. I'm more about, problem solving. I actually like the Lytel system, and they're interchangeable tips. They've been adopted by several different manufacturers of test equipment. You can go buy an OTDR that comes with a scope, and if you stare at that scope long enough, you're going to realize that it's basically a rebranded Lytel with a proprietary threaded tip. And you're going to go down a road where you're going to go, what do you mean I got to go back to my OTDR manufacturer and pay $200 for a piece of steel that I should be only paying $50 for? So no, I'm all for a Lytel. I like to plug it into a PC so I can blow it up as big as I want. They do make small little Game Boy flip-top style ones. I don't want to worry about where I left that thing, or does it power up, or is the rechargeable battery working. I like plugging it in. Plus, I can swap out the cord after I've tore the cord up. So, but yes, we sell it as part of a kit. We sell several different kits. You call us up and say, I only clean one thing, and we're going to give you a kit that only covers one thing. So,
right. Nice. Well, thank you very much. That was an incredible presentation from both you guys. But man, Danny, I mean, showing all the fibers and cleaning and everything, that was really incredible. Thank you so much for sharing that with our Atlanta chapter. And Ben, do you have any final last words?
No, I just want to thank you again, Bob, for everything and for organizing the presentation today. And we really appreciate the opportunity to present and connect with our industry during this challenging time. And we look forward to seeing you all in person pretty soon.
Yes, I'm looking forward to, I just booked my hotel for NAB, so.
Well, I just did the same. So we're looking for you there. And again, if anyone has any questions later, please feel free to call us at any time, me or Danny. We'd love to hear from you and answer any further questions you might think of at a future time.
Okay, great. Well, thank you guys. I really appreciate it. Thank you everybody for attending, and keep an eye on the SMPTE Atlanta website, and we'll announce the topic for the next meeting. Thank you again, Ben and Danny. Really appreciate it.
Thank you. Take care.
Thanks, Bob. Have a great
All right.
rest of the afternoon. Okay.
All right, you too. Bye-bye.